Okay, so let's start with phase 1 of our project. So as you can all see that I have opened VS Code here in my screen, and I have opened a folder named document phase 1. So let's start structuring our project. Okay, so let's start with all the folders that we would need. That is one code, which is going to stay as it is, not inside it, UI, right? And we cannot right now, we are not coding for phases right now, phase 2, phase 3, phase 4, but we can make a placeholder for it right now. Right here we wouldn't be coding. Okay, and then we'll have our requirements, so txt, I hope. And okay, we can have for phase 1, let me specify, and these are our requirements. So what we have here is Streamlit, OpenAI, Pinecone, Python.env, and TikToken. So what I have done here is I have specified all the versions, but you guys don't need to do that as I'm doing this on Linux right now. So I have installed dependencies issue, so that is why I'm mentioning each version which I would like, but you can just run if you guys face no problem. So now for installment, for running this, I would like to create a virtual environment. So that is done Python mv it's creating, and then we have source venv bin activate, and it's activated. So what I'll do, pip install our requirements.txt. Is the spelling right? Yes. Pip install, sorry, upgrade pip. Let me see what happened. So I typed the command wrong. It was grade pip, and then let's run our command again, pip install our requirements. Let me see why is it saying so. Okay, wait, let me do it once more because I think I forgot to save the file. Yes, that was the issue. I forgot to press Ctrl S, so that is why it was happening. I'll just take a minute for it to install all the requirements. It has started. Okay, as we can see, requirement already satisfied. It has been installed. Okay, so now let's proceed with next part of the project. Okay, what we would require is .env file. So it would be something like, so it would consist of something like OpenAI API key and Pinecone API key. That's all you need, and rest of the stuff is going to be same. That is Pinecone index name and Pinecone cloud and Pinecone region. So let me tell you how you guys can achieve OpenAI. Okay, so this is what I was talking about, Open API key. So a couple of things that you need to know before you start this project is that you need one of them is OpenAI API key. You can just log in with any of your email ID or continue with Google. It's very easy, right? When you log in, and you can just go to your key, create my key, and you'll get a key over there, and you can just copy paste. Wait. Home, and I can go to API keys, and then see you can just go create new secret key, and you'll get your secret key. You just need to copy it and paste it over to your VS Code. This is one of the things. And then second thing is a vector database. Okay, Pinecone is the vector database that we are going to store, use to store our embeddings. So it's same, start for it. You can just log in, or start for free, register first, and then you can just log in, and you will get another API key, and you just need to copy it and again paste it to the section in the VS Code where it's marked. So this is what you can achieve from here. And Open API key starts from SK something, you'll get to know it, and you just control save it, right? And then we proceed with the code part. Okay, so the very first file that we would be creating inside code would be ingestion.py, and we are here. So okay, let's import some library from future. Import from future, import annotations. Okay, Then we have import OS, we have import and we have from data classes. I'm sorry. I'm sorry. We have we will require from data classes, import data class and fields. Then we would require from pathlib, import path, and import tick token, and we have from IPDF, import PDF reader. Right, so these are almost all the libraries that we would need somehow. Okay, so let's start with the various function we would need, that is public API. So let's start making def ingest PDF. It would be like PDF path. Guys, in Python, it's very important that you pay attention to your indentation. So from PDF path, we would be string paths. Alright, we are deciding the chunk size. Let's assume we can take right now for int 400. Then we have the chunk overlap. So I told you about this chunk size and chunk overlap. It's like how many words do you want inside your one chunk. Okay, so we are determining it right now as 400, and overlap is ki how many chunks do you want to overlap in your system to maintain context of the passage or page, okay, across pages or across passages. So we have chunk overlap int equals to 50. Okay, and then we have list chunk PDF path, PDF path equals to path, and we get here PDF path again. So now we come doc name, because we don't want an extension in front of the name, so we go PDF path, not path, sorry, PDF path not stem, and this would be these brackets, by the way. Yeah, okay, and next you want pages, so we go pages equals to extract text. Please forgive me for my spelling mistakes. Text from PDF, and we give PDF path here. Alright, and then if we move on to if not pages, we want an exception, raise value error, that is function let's say no text found. Okay, and where PDF path dot name. Okay, we can do this, and then we talk about chunks equals to chunk pages. So it would provide us pages, and it will provide its doc name, and it would provide us chunk size, and it will provide us chunk overlap. This is all the information that we want from that. I think, yeah, we got it right. And then we are return chunks. Okay, So this was our very first thing where we are ingesting the PDF, like we're uploading the PDF. All right, now we talk about is extraction. Okay, it's PDF extraction. So let's make that function. Okay, sure. So we are talking about if extract text from PDF. So text from PDF, and we are passing the values PDF path, and we got a string, and we have a path, right? And what is it? It's leading to list. Okay, it would return the value of tuple inside integer and string. That's right. And then we can come niche. We are talking about reader equals to PDF reader, and we have string, we are converting it into string, and then we are talking about PDF path here. Okay, so what it does, it creates a PDF reader, and we can create a list with pages equals to this. Okay, so for let's iterate through this page and enumerate reader's page, start page. We can have we're gonna start from 1 so that it matches our PDF page number as well. It does not get confusing if we let the normal indexing start from 0. So we are starting from 1. We have text equals to page dot extract text. Okay, and or we can do this so that extraction of text from page does not break when it returns as the value none. So that is why we're including inverted commas. Or we can have text equals to clean texts, right? Okay, so we are calling the function clean text here. Let's write a function first for clean text, because clean text, and we are passing a value of text which is string, and it's gonna return a string as well. And okay, so what it's gonna do is, okay, let me just paint it right here. So we would have this. Okay, so it's just gonna resub all this. It's gonna strip something, and then it's gonna look for values and dehyphenate. So all this is gonna come inside clean text function. So that is the function that we are calling here. And we can have, but if text dot strip doesn't happen, we can have pages dot append I comma text, right? And then we can have sorry, we would get one more here which we forgot, and we can have return pages. So this function is complete, where we can extract text from PDF so far. So now what we will come to, the main part of the function would be chunking. Okay, let's make the function for chunking, like def chunk pages. So before that we move, we should get a couple of things. That is, we have to get an encoder equals to tick token dot get dot encoding, and then we have CL100 key is, right? So what it does, this loads OpenAI's tokenizer. So this is what we are going to use here. Okay, then we have def count tokens because we need to count the number of tokens to start. It's gonna take text, and then we're gonna have string, and it's gonna give us integer, and return what we wanted to return is length of encoder dot encode. What are we encoding? We are encoding text. So this is what we are getting here. So I just got the function over here because it's a bit longer function. Let me go through it completely. So what this is going to do is we have first of all our pages. All right, so we have our pages, and then it's going to tell about the list. It's going to tuple string, and then we have the doc name that's going to string, then we have the chunk size, and then chunk overlap. Okay, this is all about the information that the page is going to show. Then we have a token map for page num, text and pastes. Okay, what we are going to do is we are taking we are tracking all the tokens. Okay, first of all we are having a list which stores all the tokens in the whole complete PDF, and then the second list which stores which token comes from which page. Okay, then we are moving. Then what we are doing, yeah, token dot extend. Yes, what we are doing is suppose one page has 3 tokens, so we are just multiplying the length of the token with the page number. Then we are moving, then we are doing chunks list chunk equals to open list. So what we are doing is we are preparing for chunking. So we have a start of 0 and we have a chunk index of 0. So while start is less than length of all tokens, we are starting the loop for all token processing. So what we are doing is on the next line where we are describing end equals to min start plus chunk size, it's like we are determining the chunk boundary. Okay, we can fix this whatever size we want. We have already defined start here, and then we have also defined chunk size of 400. You can shift as per your requirement, which would look further in the code. Then we have token slice. Token slice is for extracting tokens. Then we have text equals to encoder dot decode. So what it does, it converts tokens back to text. Okay, then we have we have page number. So it's page number token page map starts, of course, as it's mentioned, it starts the starting page. It finds the starting page. Okay, then when we come to chunks dot append chunks, so it's just appending the text time, doc name, page, chunk index, and token count. Okay, and then it's just chunk index +1. It's adding +1 with the loop starts, and same with the start value. And we wanted to return chunks. Okay, so this was our chunking function. This was the main part of the function. Now let's get on to the last part of what we would need here is the data class. Okay, we can go class chunk, and we can have text string, and we can have doc name as also string. Then we can have page number also integer. Then we can have chunk index as integer. And we can have token count. As integer. So what we are doing is that we are indexing it, and we handle position with dog, and we are giving it metadata of date. Okay, metadata date equals to where my field is default factory, where it's going to be factory, and it's going to be dip. Okay, and so we can have now it's stored how chunk metadata is going to be stored, and it's going to be in the form of dictionary. Now we got to convert this dictionary into acceptable metadata that Pinecone would store. Okay, dictionary that Pinecone can store. So we can do it def to Pinecone metadata, and we are passing the value self. Okay, we are giving dictionary, and then we return. What do we return? We return, okay, sorry, let me correct this, and we are returning the we are returning text, and this is all we are returning. All right, so I think for now our ingestion.py is complete. Let's move on to the second file of this, and that would be embeddings.py. Okay, so far the flow of the project has been that we have a core for phase 1 where we have a PDF and we are ingesting that PDF, and then we have extracted text from the PDF, and now what we are in the second part of the process, that is embeddings. It's gonna convert those chunks, okay, that we have extracted into numerical form, into numerical state. So that process was known as embedding. So that's what we are going to do here. So let's start with embeddings.py, and so what we are going to do, import some libraries from future. Let me just go and copy paste from here. We can have copy, and then we can have paste, and then we can also have import time, and then we have from typing import type checking. Okay, so what we are going to do from OpenAI, import OpenAI. Okay, these are our libraries. Let me go with this, and okay, so we're gonna start from it. If type checking, we can do that, but in production this is not used so much. Sorry, I just used my terminal. I just pressed it for something. Let me go to my VNV again. Source VNV, then activate. Do not pay attention there. Okay, type checking, we are here. So we can do from co.ingestion.py, right, import chunk. Okay, cool. Then we can have okay, so we can have embedding model equals to, we have, what did I do wrong? Oh, embedding model, so we can have text. We are using embedding 3 small. Okay, this is the name of our embedding model, and then we have embedding dimension, so that is going to be 1536. That's going to be the dimension that we are going to use. And then we have path size, so it's going to be of 100. So instead of every token making an API call, we are summarizing it with 100 tokens making one API call, 100 chunks per API call actually. Okay, so this is defined. Okay, so let's create an OpenAI client. So for that we have the get client, and we are passing nothing, and then we'll get OpenAI, right? So what we are going to do, we are going to make API key equals to os.getEnv. So we are importing our OpenAI key from our env file, right? API key, so it will read our API key. And okay, if not API key, so we can have an environment error where we can define open AI API key not found. Works. So okay, and then we go return OpenAI. Oh, sorry. OpenAI. We are getting API key where API key equals to API key. Okay. So we got a client, and now let's make a function if client, if okay, yeah, let's make a function for def embed text. So there was a process that I've called it and provide a client. So what we'll do is we'll create a client and then we'll embed our user query as well. Okay, def embed text. Yeah, we are embedding the text now. Okay, that's what we are going to do. Now we are doing the actual conversion into a vector. Okay, we have text, and then we have this list of string, and we'll have a client, and we're going to have OpenAI as a client where none equals to none, right? And we are going to get the value of list inside a list of float. Is that nice? Okay, so what we are going to do, if client is none, create one. So client equals to get client. Okay, and then we are going to do all embeddings equals to, sorry, forgive me, all embeddings lists float, right? And we are making an open list, so this will store all the result. Okay, now we will create batches for in range. We can have from 0 to length of text, and we are gonna go till batch size. Okay, and we are going batch equals to text, and we have I plus batch size. Okay, so it extracts the current batch. That's what this do. Now we are doing the actual API call making. So what we are going to do is response equals to client dot embeddings dot create. So and then we'll have model as equals to embedding model, and we will have input as batch. Okay, so this is done. Oh, okay, embedding model, input as batch. Okay, now we have to store the response. So what we are going to do is we will store it by batch. So embeddings equals to item dot embedding for item in sorted response dot data, right? And we have key equals to lambda, and we have x dot index. That's right. So it would be all embeddings dot extend batch embeddings, right? That's right. Okay, and then what we are going to have, if I plus batch size is less than length of text, we will have time.sleep 0.05. okay, and we can have return all embeddings. And we have finished this function, and then we can just have a very simple wrapper for it. Def embed chunks. We can have chunks list chunk, and we are having a client as OpenAI, and we can have none as none. Okay, and this is giving us a list of float. Okay, so this is a very simple wrapper for it, so that we don't need to call it again and again. So we have text equals to c dot text for c in chunks, and we can have return embed text. And client. Okay, so this is the wrapper for it. And then yes, now what we are doing is, first we embedded the whole PDF. Now we are embedding the user query. Okay, this converts the question into a vector, where then we can compare both the embedded vectors. So what we are going to write, def embed query, and we are going to have query is of type string, and we have client as OpenAI, and then we have none. Okay, what else do we have here? Right, why is it throwing me an error? Okay, and we can move here, and it will return me a list of float. That's what it's gonna return me. And we can, so it would return embed text into query, and we would get a client. Okay, from 0. Yeah, and I have made a mistake here, sorry, and it would be client, whereas my code. Yeah, okay, and we are done for embeddings.py. I hope that you got the function. Okay, so we completed embeddings.py. Next would be vector store.py. Okay, so we'll start from same. Let me get the two most same library. Let me just copy paste. Nope, we are not doing this, and we are just this, and we need import UUID, and we can do import. No, we can have from. Okay, let me get this from here, and I can get this from here. Okay, and then here we're going to store, so we need Pinecone actually here. So what we are going to do from Pinecone, please, I make a lot of mistakes. Import Pinecone, and we need serverless spec. Okay, so what it does, it's the Pinecone SDK, so it will create index, store vectors, query vectors, or delete vectors, right? And then we can do, if it's just type checking, type checking from core dot ingestion, we can have import chunk. Okay, it's just for hinting, it actually isn't done in production. So what we can do is, now we can create index name. Okay, that is, it's going to be os.get env, and we are going to have Pinecone index name as document. So you guys can see we had it in a env file, Pinecone index name, Pinecone cloud AWS, and dimension. So we are just defining all that over here. Okay, and we have this here, and then I can go cloud. Okay, cloud equals os dot get env, and I could have Pinecone cloud as AWS, and then we can have I forgot to put the document here, and then we can have dimension. No, we'll have region first. Region, let me just dimension, and we would have matrix, and what else we're gonna have, and we'll have upsert batch. We're gonna tell how much is the batch size it's gonna be. Okay, so let's start from region. Region is os.get env, and I'll be like Pinecone region is US East 1. Okay, dimension, we will have 1536. We have already mentioned this in the embeddings. Matrix, we are going to use cosine. So this is the cosine similarity that we would be performing to get the similarity between PDF embeddings and user query embeddings, right? And upsert batch of 100 we are using. So now let's get into creating an index. So what we have to do is we have to return a Pinecone indexed object, right? So we can make a function from that, def get index, and we are doing this. So what we are doing is API key equals to os.get env. If we don't have we are creating the index if it doesn't exist. So just read the Pinecone API key. So we'll have Pinecone API key. If not API key, so we can say raise environment error. Okay, and we'll be like Pinecone API key set. Okay, we can have PC equals to Pinecone API key equals to API key. API key. Okay, so we are just having a Pinecone client right now, and we get existing equals to name for IDX in PC dot list indexes. So what we are getting is name of all the existing indexes, and if index name not an existing, we are just going to pc.create, right? Index. So we have name equals to index name, index. Where did you go? Yes. So why is it not selecting? Okay, fine. Index name, and then we're gonna have dimension. No, and dimension equals to dimension, and then we're going to have metric equals to metric, and we are going to have spec equals to serverless spec, that is going to be cloud, right? Equals to cloud, and we are going to have region equals to okay. And we created the client, and we can just do return PC dot index name. Okay, so we have created a Pinecone API index, and we have also read Pinecone API key. Now what we are going to do is we are going to store the vectors, so we can make a function which can be like def upsort chunks. Okay, so we have here what you can say as just what did I do? Okay, and we have again here I have chunks as list chunk. Okay, and we can move. Yeah, we can. Yes, we would need embeddings. Okay, embeddings is again list, and we have list, and we'll get a float value. Okay, so yes, and this would give us an output of integer where my index equals to get, what did I do? Embeddings list. Okay, we will have get index. Okay, now we're going to prepare a Pinecone payload, that is okay. So this is going to be our Pinecone payload. Do not worry guys, you'll get all the code in my GitHub repo, and the link would be provided. So what we are doing is we are taking the vector ID here, and then we are appending the vector, creating Pinecone record, and then we are telling how much batch upload we are going to do. All right, so next we'll be talking about how our retrieval function is gonna do. This is like what powers RAG, so that would be our def query index. All right, so what we are going to talk about is query embeddings. Okay, it's gonna be the list of float, we know that, and then we are going to have top K. Let's assume we are asking for the top 5 similar chunk retrieval, and then I have filter doc string where my none equals to none. All right, and the output would be, I would get a list of dictionary, because that's what Pinecone is doing. Yeah. Okay, so what we are going to do now, we are going to get an index. So we'll be index equals to get index, and then we'll talk about query keywords, text equals to this, and then vector is equals to query embeddings. We'll have top K as top K, and we would have include metadata as true. Okay, so this would be our index, and what we can do now, we will do a little metadata filtering. So what we'll say, let me come here, we were a filter doc, and we were going to create a metadata filtering. So filter doc equals to filter doc name, and we are going to get a filter doc. So response goes to our index docs query, and then we're going to store the results. So what we are going to do is convert Pinecone result into a simpler format. That's what we are going to do here, and then we are returning the result value. We are going to create 2 more small functions. That would be for delete document, and we are passing the doc name just string, and it will be giving out a value of none. So what we are doing is we are index equals to get index. Okay, and we are doing index dot delete. We are going to filter it with doc name. Yeah, and then we are going to sequence it. Sequence with doc name. Okay, so we have made a function for deleting, and just let's get for where we want to return our index stats. That's like total vectors and dimensions. Okay, so we can get index stats, right, and we are just gonna pass them into dictionary. What we are doing is index equals to get index, and then we are going to stats equals to index dot describe index stats, and we are going to return total vectors. All right, and that's gonna be stats dot total vector count, and we can have dimension as my spelling is correct, dimension stats dot dimension, and we can have index name. So we can have index name here. Okay, so we got I'm sorry. It's showing an error here because I forgot to put it inside inverted commas, and it's gone. All right, now it's pretty much done. We can also create a function for shows which documents exist or not. So we can have like list index documents is my I always miswrite it, and yeah, list index documents, and then we can pass as index equals to none, and we are getting a list of string. Oh, I'm sorry, I didn't pay attention. Yeah, so what it does, if index is none, all right, so it will get index equals to get index, right? So it will fetch with a 0 vector to get any result. So what we are going to do is 0 vector and equals to 0.0 into dimension. Okay, and what a response is going to be equals to index dot query, and we are going to get vector equals to 0, and we are going to get 0 vec, and we are going to get top k as equals to 10. Oh no, we decided top k 100, and we can get include metadata equals to true. Yeah, so this is our response. I'm sorry, I made a mistake there. Top k, yeah, vector response, and we want to talk about docs. Docs is going to be list. It's going to be docs going to be list. Okay, so this is pretty much our vector store.py, and I think we are done. Okay, so now we're going to make another file that's going to be generation.py. So let me just recall how far we have come. We have got a PDF, we have ingested that PDF, we have extracted that PDF, we have converted that PDF into a vector, embeddings. Okay, we have embeddings, and then we have stored them in our vector store.py, that is Pinecone. Okay, so the next step is going to be generation.py. Generation is the main part from where our system is going to generate the answer. Okay, so let me just go, and we can get this from here. We can go here. Sorry, I have a little bit cold, and we can get from typing import generator. Okay, and we can have from OpenAI import OpenAI. So we're going to have a system prompt here. Okay, how we want our system to work is the main function of RAG is that we tell our LLM to function with only the relevant information that I provide you and answer from that. So what a system prompt is going to be, so this is going to be a system prompt where we are telling that you are Document, an enterprise document assistant. Your job is to answer questions using only the context passages provided. Okay, so this is my context that I'm providing to the LLM. Okay, and I have some rules. The rules are that base your answers strictly on the provided context. Do not use prior knowledge. Cite your sources. If the context does not contain enough information, say I couldn't find a clear answer in the uploaded documents. Be concise and factual, no filler phrases. If multiple passages are relevant, synthesize them into one coherent answer. So you can customize your system prompt, but because my document for my enterprise model assistant document, I need these rules, so I have put these rules on here. So this is the template that is sent to GPT or any LLM model. We are using GPT here. Okay, so what we are doing now, we are going to make a user template here. User template. So it's gonna be context passages. Okay, and yes, embed, and then we're going to have a little context block. And then we are having a question. We will ask our question, and then we are going to do answer with citations. Because if you remember, when in the starting of the video, I previewed our document, how it's gonna look. So when we were running a query, it was also showing all the citations, all the chunks that the information was retrieved from. So answer with citations, and we are going to end this. Okay. Okay, so what we are going to do now, we are going to write a function which prepares retrieve chunks. So what we are going to do is def build context block. So we are going to have retrieved chunks here, and we are going to have list dict, and it's gonna return me a string. Okay, and then I'm gonna have is equals to an empty list, and for I can just have chunk in enumerate, and we are going to talk about retrieve chunks, and start again going to be 1 because I already told to match the index. And then we are going to have lines dot append. We're going to have, so this is what we are going to have for the append. We are going to have the doc name, we are going to have the page number, and we are going to have the text. Okay, and we are telling it to return \n and not join lines. Right, and what did I do wrong? Return PC different solutions. Why is it skipping this? Okay, so this was supposed to come here. Hopefully the suffix set, yes. Okay, and now we are going to do LLM call. So let me get on to that. We are going to make LLM model as we are having LLM model equals to, we are using GPT-4o mini. Okay, and if you want for higher quality, you can also swap any model you would like. So we would have, I have function here to generate answers. So it's going to be what we are giving question string, retrieve chunks, stream, and model. So, and it's providing me with a generator with string. All right, and API key, open API key is being used here, which we have to specify in our .env. Okay, here we have to write it, and then it's being used here. Right here, and then if not API key, we are raising an issue, and then client is OpenAI. Right now, if you're talking about if not retrieved chunks, so if not retrieved chunks, we can have a message equals to I could not find relevant passages. Okay, you can write anything, I'm just making it short for the demo. And if stream, so I can have def empty, and I can have yield message of return return empty. Now what did I do? And then return empty, and I can have return message, right? How it's showing. Okay. Yield message. What? I could not find. Oh. Who cares? I am just a klutz. XYELT. Yeah, yield method. And yes, so now we can also have return message. Let's have a little context block. Okay, so we can have a little context block. So what we are doing here is we are building a context. Okay, so building user prompt, right? User message equals to user template dot format, and then we can have messages which would be ChatGPT format. So we can have equals to, we are talking about role, and we'll get a system, and we got a contest, content, and then we got a system prompt, right? This is our ChatGPT message formats, and then we are going to also have again role, role, and we're going to have system, content, and we are going to have user message. So what else we have here? It's going to be missing a little comma here and here as well. Okay, now if we are talking about if streaming is possible or not, so we can have a little if the whole answer is generated or not, or if you would like to have a stream. So yeah, this is if stream, so written stream response, else we can say completion create. So we are waiting till the whole answer is completed, and then we also have a function where we can tell define stream response. So client is OpenAI, messages are list, we'll get a list dictionary, and the model is string, so it's generating. So we can just chat completions.create and as stream and yield data. So this is our completion of generation.py, and let's save this and let's move on to the another file, and that is pipeline.py, and that is literally the last portion of our code. Okay, so we are continuing with pipeline.py. So let's get all the libraries that are required. So we are from future, import annotations, and we can have from data classes, import data class, and then we can have from pathlib, import path. All right, and then we can have from core dot ingestion, import ingest PDF. In this pipeline.py, we are not going to have anything new. We are just what we have structured so far, we are going to make it in a flow. And so all the files that we have made and functions, we are just going to import here, and we are going to make a flow of a pipeline. Okay, so from embeddings, core.embeddings, we are going to import embed chunks and embed query, and then from core dot vector store, we are going to import absurd batch, no, absurd chance. I wanted absurd chance, and we are going to have query index, and then we are going to have delete document, and then we want get index stats. Okay, and then we have from course generation. Where is generation? Okay, import generate answer, right? Yes. Okay, now what we are going to do is we are going to make a result model. Okay, so it's going to be super easy. We have data class, and we are going to say class ingest result, right? And we are going to say doc name is string, and we can have chunk count, that's gonna be int, and then we can have page count. Oh, I'm sorry. And it's gonna be chunk count, and then it's gonna be page count int as well. And then we are going to have total tokens int, and we can have status. We are going string equals to success, right? And we have error is also a string, right? So this is a data class for ingest result, and then we are going to have one more data class for query. Okay, so that's going to be class query, no, query results. Okay, so what we are going to have answer string, and sources is gonna be list dict. And so what we are doing is, what we are doing here is we are getting whole context of the text. All right, query is string, and then you have top key in. So we have defined two data classes in our result models. Now what we are going to define here is ingestion. Okay, how finally ingestion is going to work. So we are going to make a little function for ingestion, define ingestion document, right? And you're going to have PDF path as a string, path, and then we have chunk size, that is int equals to 400, and chunk overlap we decided on int 50, so sure, why not. And then we have progress callback, that is length, and it's gonna give me an ingest result. Yes, so let's start. PDF path would be determined by path, right? PDF path, alright, and we can have why am I not able to come here? It's tabs here. Okay, so what we are going to do is some try, And now we are going to talk about step 1, that is going to be if progress callback. Okay, this is chunking. Okay, so progress callback. So what we are doing is we are extracting and chunking 0.1, and then what we are doing is chunks equals to ingest PDF, and we are providing PDF path, and we are giving it chunk size, and we are giving it chunk overlap. Okay, this is the first part. This is the chunking process. So now we are going back. Now we are going to step 2, that is embed. So if progress callback, we'll have progress callback, and we'll go generating embeddings, right? And we can have embeddings equals to embed chunks, and we'll be providing chunks inside. Okay, then we'll come for the third function, that is upsort. So if progress callback, we will come progress callback, and we are telling we are uploading to the vector store. Yeah, and we can say upsort chunks equals to chunks embeddings, right? And then if we are talking about finally progress callback, we have progress callback, and we are saying we are done. Okay, now we are talking about pages. Okay, pages equals to how we want. We just want to show the sorted pages, so we are just showing ingest result. So it's the same thing, doc name, chunk count, and at the end we are showing an exception as E. So what happened is if we are unable to find any concrete if we are going out of bounds, so it will send us an exception. Okay, so next part is query, how we do query generation. Let me just show you. Def query document. Okay, and so what this is going to do, it's getting a question that is string, we are getting top k chunks, and stream is bool, filter doc is that. We are having question strip, and if not a question, right, value error. Then we are having two things, that is retrieve. Okay, so there is the embed query question, and then generate. So we are generating the stream. Okay, answer generate equals to generate answer, and then question sources, else answer generate when completely it gets the whole answer. So that is our function for queries. And then we have a very small two utilities present with them. So it would be def remove document from here, and we'll get doc name, that is string, and it'll be giving us none, because yes. and it would be delete document, and we are passing doc name here. Done. Okay, and then we have just one more, and we have def index stats. No. Stats, and we are going to talk. It's going thick. Sorry. It's going thick, and I have written get index stats. Right, so it will return the current Pinecone index statistics. And so this is our complete pipeline.py. So our whole core is completed, except we have init.py as well in this. So let's just create, and we can just write, document core base here, our package, nothing else, and we can just save. So our whole core is completed. We had ingestion.py. We saw what happened in there. We are ingesting a PDF, and we are extracting the text, converting into chunks. Then we are moving on to embeddings.py. Okay, so the converted chunks needs to be converted into vector. That is known as embeddings, and we did this conversion here. We also converted the query into embeddings. All right, then we had vector store.py, because now that converted embeddings, vector data needs to be stored somewhere, so vector database. So that is happening here. Then we had generation.py. Generation.py was responsible for generating your answer from the LLM. It was responsible for the prompt engineering, and generating an answer and citating. Pipeline.py is responsible for your whole flow of the pipeline, and how functions need to be called and how they are structured together. Right, so this is our main RAG code. And good thing about is that we are not going to touch this code anymore. We would be just making simple changes in pipeline.py for phase 2 and phase 3 and phase 4 upcoming videos. But other than pipeline.py, none of the other files would be touched. Now to see what we have done so far, we will just get UI. Let me make app.py inside UI, and let's continue. Okay, so this is our app.py. Nothing special here. This is completely for UI purpose. There is no logic here. It's just Streamlit syntax over here. So we can see, as we can see from .env, import Streamlit as st, and then we are setting the page config as page title, and then we have an icon. You guys can customize as per your requirements what you would like to keep the name. Okay, then we have missing env checks, that this is for API calls. If you guys have not added your API key, so this would send a warning. Then we have the syntax for sidebar, tab bar, ask bar. This is all like pure UI Streamlit syntax, so does not need a lot of logic and code. It's very easy to understand. You guys will get this link to my GitHub repo. From there you can copy the code directly for that. In the description box you'll get it with rights and markdown question tab. And then when I'll show you finally running the this UI, you guys will understand more that which tab and which part was representing what. And then document tabs, so here it says index documents, refresh. So this is another page inside that application. Okay, and accept exception at E. So nothing much, and let's start. Okay, so let's run app.py, and it would be Streamlit run UI app.py, and it will open your app in browser. Okay, so as you can see, this is the sidebar, and you can fix the chunking size and everything, chunk overlap, top K chunks, and whatever. You can upload your document from here. Let me just get a random file which I can find. Subset closes. Please don't look at the quality of the file right now. Okay, and then we would say ingest document. No module name py-pdf. All right, so what we gotta do is we can open another terminal and let's just source env, then activate. I forgot to add py-pdf in my requirements dot pip install py-pdf. Forgot to add it. So yeah, successfully installed, and now we got to restart it. Hopefully it works this time. It's just gonna take a second and it will pop up it in your browser. Yes, and let's try uploading again. You select all files and you go to the file where I have picked one. Okay, I think it's only approx 5-6 pages, so we can reduce this. Okay, and ingest document. Yes, so click on this ingest document, and as you can see, it's generating embeddings, uploading to vector store, and then the next step we'll see done. So what we did right now is that we uploaded a PDF, we ingested the PDF, the text was extracted, then those extracted text, which we are calling chunks, are converted into embeddings, and then they are stored to vector.py, Pinecone database. So the process of ingestion till storing in our vector database is completed. Okay, and then it says ingested and the temp id, it is storing it. As you can see below, it also tells us 13 chunks, 6 pages, 3647 tokens in total. So it was a relatively smaller PDF. Now let me ask my question. So let's ask a question. Let's say, what are just business development outputs? Okay, let's ask, and it is working, it's processing, and just in seconds we'll get the answer. So as we can see, business development outputs include the following items: sales, decks, pitches, lead list, prospects. This is the answer, and these are the top 5 chunks sources. Okay, जहाँ से ये answer extract होके आया है. So let me also show you if this is saying the right answer. Let's cross verify from the PDF. So here's the PDF, and yes, it says all business development per customer, assigner, partner, any goodwill, and assigner shall log and deal activity in company CRM and shall not maintain separate parallel or shadow records of these customer or pricing. So yeah, it told us exactly these answers, right? Yes, totally correct. So phase 1 of our project is completed. This is what we talked about, that we could ingest. The core working of RAG pipeline is this. Now we'll move on to the